Teacher Rekha Agrawal is here again with you to facilitate, to conceptualize degree of freedom and errors in hypothesis testing while dealing with inferential statistics in behavioral sciences. You may recall your last session with me when we discussed about z-scores, how they may be obtained and how we may use them in drawing conclusions about the reliability of different sample statistics. Did you complete your assignment which I gave you in the last session? See on the screen how my students computed the reliability of the standard deviation of the data on which we were working in the last session. Did you also get the same results? Good. Now I am sure that we may work on the next concepts which are essential to understand while we are working with inferential statistics. Let us start with the story of the day when we were celebrating the Deepotsav on the eve of the Deepavali festival vacations in our department. We were all 11 in number, including one serving staff. The meals were served on the table and all the 10 members ate and enjoyed the food as per their choices. In the last, all remaining food was to be finished by the serving staff as there was no other option to preserve or consume the remaining food because the Deepavali festival vacations were ahead for a longer period. Therefore, the serving staff had no choice and he had to eat all whatever was remained. In this case, if we analyze the situation in terms of freedom for eating as per one's own choice, the 10 out of the 11 persons had full freedom, whereas the last person, the serving staff, had no freedom to eat as per his choice. On the other hand, if you peep into the situation where meals were arranged for more than 1000 passed out students of the university in a post-convocation session, you may find that every student could eat as per his own choice and no one was compelled to eat what he did not want to. Here, you may also observe that if a particular food is liked by some students at one hand, at the same time the same food may not be a choice of some other students, and this could be applied to all kinds of food available there. Now, if we compare both the situations, we may find that in the second situation, on account of the large number of persons and hence large number of choices available, every one of them could eat normally, keeping his or her choice free. None of them was forced to eat other than the normal choices. The specific choices of some persons could be adjusted with the disliking of other persons for the same thing, and thus every type of food was consumed by the entire group normally. In contrary to this, if we look into the first situation, the number of the cases were less and hence the number of choices were also less. This resulted into more consumption of some specific type of food, and therefore, other type of food remain less consumed. In this situation, everyone except that of the last one of them was free to remain normal as per his own likings or dislikings. He had to accept whatever was remained available for him, which may not be considered as normal for him. Before we analyze these two stories in terms of inferential statistics, we should note that for drawing inferences from the sample data, the data of that sample should be normal. That is, it should represent the population. As we have seen in the second story, where every case has a freedom to behave normally. But at the same time, it is not applicable on the cases of the first story, where the size of the group was small. Amongst them, one had to restrict himself from being normal in order to keep the rest others behaving normally. Therefore, at this point of discussion, we may realize that in the cases of a small sample, the total number of cases may not be taken into account to get a normal data, which is a foremost requisite of the inferential statistics. Hence, in such situations, the one case which we assume has no freedom is to be eliminated from the group in order to obtain normal data on the sample. Thus, after deducting the one, the remaining number of the cases of a small sample is termed as degree of freedom of that group. In other words, the degree of freedom of a group may be the number of cases in a group who have the freedom to behave normal. To conclude this part of the session, it may be said that for drawing inferences on the basis of the data drawn from a small sample, we use degree of freedom instead of the total size of the sample. Here, you may recall the discussion of the previous session when we deducted 1 from the size of the sample while we were computing standard deviation to estimate it for the population. The concept of degree of freedom is used to bring more precision in the findings of the research while using inferential statistics. Besides degree of freedom, in the same session, I also used another term, that is the term error, and try to interact upon it for the purpose of testing null hypothesis. But due to lack of time at that place, this term could not be discussed at length to get an insight into it. Now, you also realize the significance of this term, as in behavioral sciences, it is next to impossible to get an error-free data. Error is always a part and parcel of any observation which is made on human behavior. No researcher can get rid of it. It may only be managed either physically or statistically. Therefore, an understanding into the place of error in testing hypothesis becomes essential for a human behavior scientist. Let us now discuss the concept of errors in testing hypothesis. we know that the null hypothesis in any case either is true or it is false. In the same way, we may take two types of decisions. We may reject it or we may retain it. In this way, there are four possibilities of occurrence in respect of testing null hypothesis. You may see these possibilities on the screen, shown in the form of a table. Two of them are correct decisions, whereas other two are not because of the error in the results. It is obvious from the picture that there are two types of error which may be committed by any researcher. These are type 1 and type 2 errors. Actually, you see on the screen, if we reject null hypothesis and it is true, it is type 1 error, and if we retain the null hypothesis when it was false, it is type 2 error. Do you remember how my two students worked for the estimation of the level of IQ of my newly admitted students? They calculated the mean of the sample data as 123, whereas the value of population mean was 115. If our sample was the true representative of the population, it had to yield 115 as mean score. The null hypothesis in this case was that mean score of the sample data is equal to the population mean, that is 115. But in this case, the obtained mean value is 123, which leads us to reject the null hypothesis. The logic in rejecting the null hypothesis is true. A sample mean, this deviant would occur less than 5% of the time. Therefore, it seems more reasonable for the researcher to believe that this sample mean came from a population with different mean from that specified in null hypothesis. The probability of a type 1 error is indicated by the Greek letter alpha. On the other hand, if we retain null hypothesis and in fact it is false, we have committed a type 2 error. How it may be that? Unknown to us, the mean of the population is really 121. See in the figure shown on the screen. The obtained mean value as 123 for the case which was handled by my students. We have to test the null hypothesis where population mean is 115. This you may see on the screen where two sampling distributions are shown. The true distribution is shown with yellow lines and centered on 115, the true population mean. The other is the sampling distribution of population mean that would occur if the null hypothesis is true. It centers at 115. The sample mean actually belongs to the true sampling distribution, but to test the hypothesis that the mean of the population is 115, we evaluate the mean according to the position in the sampling distribution shown in blue lines. Relative to that distribution, it is not deviant enough so that the null hypothesis may be rejected. Our decision therefore will be to retain the null hypothesis. It is of course an incorrect decision and committing type 2 error. The probability of a type 2 error is indicated by the Greek letter beta. These two types of error may be managed by maintaining a balance through the decision taken for the limit of levels of significance. If they are kept very stringent, they may lead to type 2 error, and if the level of significance is set at low level, there are chances for committing type 1 error. It is common for researchers to evaluate the outcome of the test according to the 0.05 or 0.01 level of significance. They tend to give reasonable assurance that the null hypothesis will not be rejected unless it really should be. At the same time, they are not so stringent as to raise unnecessarily the likelihood of retaining false hypothesis. In this course of discussion, we have conceptualized the phenomena of degree of freedom and the way it helps in drawing inferences when the size of the sample is small. We have also discussed the types of error in testing hypothesis, their nature, and also the ways that may be managed. Now, this is the time to recapitulate the meaning of some very significant terms which we shall be using repeatedly in the next coming discourses regarding conceptualizing inferential statistics. Some of them are normal probability curve, levels of significance, z-scores, degree of freedom, types of error, standard error of statistics, etc. Refresh yourself and join next session with me to discuss upon the concept of one-tailed and two-tailed tests. In testing hypothesis about the difference between two groups, till then, my best wishes.